Hello, sixth graders. I hope you're well. I hope everyone had a great weekend. It's the second week of November. So let's look at a few problems that you will encounter this week as you go through the second lesson on equations, and then you're going to take your mid-module quiz. All right, so what we're going to look at here is solving for our variable. Now, last week you solved for your variable by adding or subtracting. So look at number 1. It says 3 times x equals 12. Well, last week we talked about doing the opposite operation. So last week when you saw x plus 3 equals 10, to get x alone, you would subtract 3. So we're doing the same thing, kind of. We're doing the opposite operation. So what is the opposite of multiplication? Division, right? So we're going to divide both sides of the equal sign by 3. Everything you do, you got to do twice. So this says 3 divided by 3. Well, 3 divided by 3 is 1, and 1 times x is x. So x is equal to 12 divided by 3. 12 divided by 3 is 4. And that is the answer. And then, of course, we can check it. If x is 4, does 3 times 4 equal 12? Is that correct? Yes, it is. All right, now look at number 2. This says x divided by 3 equals 12. 3x divided by 3 equals 12. So what is the opposite of dividing by 3? Well, the opposite of dividing is, multiplying. I was about to put a 4 for whatever reason. The opposite of dividing by 3 is multiplying by 3. So we're going to multiply each side by 3. Well, if I multiply by 3, I get to cancel out those 3's. 3 divided by 3 is 1. 1 times x is x. Is equal to 12 times 3. Well, 12 times 3 is 36. So then we get to check our answer. Does 36 divided by 3 equal 12? Is that correct? Yes, it is. Excuse me. So there's our answer. Number 3, this says 3 times x equals 6. 3 times x. What's the opposite of multiply by 3? Division. We're going to divide by 3. So 3 divided by 3 is 1. 1 times x is x. So x is equal to 6 divided by 3, which is 2. And then we check our answer. Is 3 times 2 6? Yes, it is. All right, now all of these you can do in your head, but then when you get to a problem like number 4, you're like, oh, okay, well, I'm glad I know the steps, right? So number 4 says 7.6 times x equals 62 and 32/100. So what's the opposite of multiplying by 7.6? Well, that is to divide. The opposite of multiplication is division. So 7.6 divided by 7.6 is 1. So x is equal to, use my calculator, 62.32 divided by 7.6. And my answer is 8 2/10. 8.2. All right. Look at number 5 up here. This says x divided by 2 equals 16. So what is the opposite of dividing by 2? The opposite is multiplying by 2. So I'm going to multiply both sides by 2. 2 divided by 2 is 1. I have x on the left side by itself, and 16 times 2 is 32. So then we can check it. Does 32 divided by 2 equal 16? Yes, it does. So be careful. A lot of people on number 5 would look at that very quickly and say, oh, it's 8, because 2 goes into 16 8 times, but that's not what it's saying, right? You got to think of the opposite operation. Number 6, 2.5 times x. The opposite of multiplying by 2.5 is dividing by 2.5. So 2.5 divided by 2.5 is 1. 1 times x is x equals 40 divided by 2.5 is 16. X is equal to 16. All right, how'd you guys do? All right, let's look at the word reciprocal. Reciprocal means you take a number and you flip it. right? So the first question on this page says, what is the reciprocal of 1/4? Well, I would just flip it, and I would get 4/1, which is 4. So basically, reciprocals, if you multiply reciprocals, you always get a 1. So if I multiply these two fractions together, I get 4/4, which is 1. That's what reciprocal means. What do you multiply by to get 1? So basically, you flip them. All right, so the next question, what is the reciprocal of 3/5? Well, if you flip 3/5, you get 5/3. That's the reciprocal. So when you have problems like 5 and 6, where you have multiplication by a fraction, well, one way you can get rid of times 1/6 is to multiply by its reciprocal. Because technically this is a multiplication problem, right? And the opposite of multiplying is dividing. So we would divide both sides by 1/6. Well, how do you divide fractions? You keep it, change it, flip it. So dividing by 1/6 is the same thing as multiplying by its reciprocal, multiplying by 6/1, which is going to be 18. So that's how, when you have a problem where you see multiplication by a fraction, the way we're going to solve it is by multiplying. The way we're going to cancel that fraction is by multiplying both sides of the equation by its reciprocal. Multiply both sides of the equation by its reciprocal. So these cancel. We're left with C is equal to 3 times 6 is 18. And that is the answer. All right, number 6, 1/4 times M. So what is the opposite of, or how do we cancel out times 1/4? Well, you multiply by its reciprocal. So the reciprocal of 1/4 is 4. So that's what we're doing. We're multiplying both sides by 4. So 8 times 4 is 32. So then you think, okay, well, is 1/4 of 32 8? Yes, yes, it is. I know it's correct. All right, look at number 7. This isn't, I mean, you can still multiply by its reciprocal, or this one is easy because the opposite of multiplying by 7, you just are going to divide both sides by 7. So x is equal to 8. Does 7 times 8 equal 56? Yes, it does. I know we're right. All right, look at number 8. There is multiplying by 2/3. How do you cancel out times 2/3? You multiply by the reciprocal, which is 3/2. And we do everything twice, 3/2. So 2/3 times 3/2 is 1. 1 times x is x. I'm going to turn 12 into a fraction. I can multiply straight across, or I could simplify the 2 and the 12. But anyway, if I multiply straight across, I get 36/2. Well, I know that half of 36 is 18. So is 2/3 of 18 12? Is that correct? Well, I know the 3 would cancel. 18 divided by 3 is 6, and I know that 2 times 6 is 12. So that is correct. All right, number 9. I see my variable being multiplied by a fraction, so I'm going to multiply by the reciprocal. So the reciprocal of 1/4 is 4/1. I'm going to do the same thing to the right side of the equal sign. 1/4 times 4 is 1. And then on the right side, I have 2/3 times 4/1. Well, 2 times 4 is 8, and 3 times 1 is 3. I could leave it as 8/3, or I could turn it into a mixed number. 3 goes into 8 2 times with 2 left over. So 8/3 is the same thing as 2 2/3. Or you would also, if you would turn it to a decimal, you would get 2.66666. All right, number 10, Susan raised $234 by selling 18 equally priced wreaths for the band fundraiser. Write an equation to find the price Y of each wreath. So if her total was $234. We're going to let our expression equal $234. Well, she sold 18 and each wreath was the same price, then we would multiply 18 times the price of each, which we don't know. So we're going to use Y. And that's where we got our total of $234. So there's our equation. Now it doesn't tell us to solve the equation, but we could. We could divide both sides by 18. So 234 divided by 18 is 13. The price of each wreath is $13. So that's it solved, but actually, if we just read the directions, we're just worried about the equation. Number 11, Bobby, Kate, and Rebecca earned a combined 12 points during their team's game. Bobby earned 6 points and Kate earned 3 points. Write an equation, oh, that shouldn't be capital, to determine how many points Rebecca earned. So I'm going to do this up here. I'm going to do number 11 up here. All right, so we know that Bobby earned 6. We know that Kate earned 3. And we don't know how much Rebecca earned. So Rebecca will say earned an unknown number. But we do know that altogether they scored 12 points. So we can simplify that equation because we have two constants, so we can add those constants. 6 plus 3 is 9. 9 plus x is 12. So that would be our equation. If we wanted to solve our equation, we would subtract both sides by 9, and we would know that the answer is 3. Rebecca and Kate both scored 3 points. All right, number 12, Heather is planning a dessert display. She needs 4 ounces of strawberries for each dessert. Heather is not sure how many desserts she will make. Write an expression. Now remember, an expression does not have an equal sign. Write an expression with a variable that represents the amount of strawberries Heather needs for the desserts. So she doesn't know, what did it say? She's not sure how many desserts she will make. However, she does know that for each dessert, she will use 4 ounces of strawberries. So how many desserts? We don't know. So we're going to let x equal the number of desserts. And I have to do this because it told me to identify what the variable represents. X represents the number of desserts. So I have that last set of directions finished. Now I have to write an equation with a variable. So x is my variable that represents the amount of strawberries she'll need. Well, we don't know how many she's going to need. However, because we don't know how many she's going to make, but we do know that however many she makes, we got to multiply by 4. So 4 times the number of desserts she'll make. And that tells us how many strawberries, how many ounces of strawberries she'll need. So this is my expression for x. Now I'm saying, what if Heather has 24 ounces of strawberries? How many desserts can she make? So now I have a total number of ounces. So we're going to take our expression, we're going to set it equal to 24, and now we have an equation. An equation has an equal sign, right? So this is my equation, and now it says show all work to solve it. So how do you get rid of times 4? We would divide both sides by 4. So x is equal to 6. And what does x represent? Well, we wrote it right there, didn't we? X represents the number of desserts she'll make. And that is the question. How many desserts can she make? And the answer is 6. Okay? So I wrote my equation, I showed my work, and I solved it. I've done everything that Part B and Part A asked me for. So when you're answering those short response questions, make sure you go back and read the question and make sure you've done all the parts so you'll get full credit. All right, guys, I hope that helped you guys as you get ready for this week, Monday and Tuesday at least. And then I'll probably make another video for Wednesday, Thursday, and Friday. Y'all have a good one. I'll see you later.